Good afternoon, and welcome to this webinar about advanced AI. My name is Nick Droch. I'm a senior software engineer at Microsoft. And so in this session here, we're going to introduce you to the more advanced artificial intelligence and machine learning services that you can leverage on the Microsoft platform. So earlier this week, my colleague Jan has been discussing our cognitive services. So one of our ready-made services for AI that you can integrate in your applications. So today we're going to look at how you can build your own machine learning algorithms and what are the different options that you can leverage here in our platform. If you were to have any questions, feel free to post them in the conversation window. I'll try to get you an answer as soon as possible. Okay, so let's get started. So machine learning and artificial intelligence. So there's numerous scenarios where you can leverage AI and machine learning. And here you see a case from a company called eSmart Systems. And they are using machine learning to do kind of detect defects in electricity equipment, so high tension power lines. So you need to detect these specific disks if there are any issues with those. And so they're using machine learning to actually detect and do object recognition on those images. So they have drones flying all around these power lines, taking pictures of those that equipment, and so they apply machine learning and actually deep learning algorithms to actually be able to detect where there's any defects or places where they would need to have maintenance happening. So that's one very specific scenario. Another one that you've worked on is you'll again in the computer vision area, where we actually are using a bunch of cameras to detect snow leopards and the presence of snow leopards in the wild. That's kind of a more of an ecological project, but again, it's applying artificial intelligence, computer vision algorithms to do classification of specific species. So you need to be able to detect, is a given animal, is that a snow leopard or maybe some other creature? And so that's something that you can do using AI algorithms. So these are kind of two samples to kind of demonstrate what you can apply with artificial intelligence and machine learning. Now, if we look at the Microsoft AI platform, it's really front and center in our cloud platform. So our Azure platform contains a number of AI services, and they're really built into a number of services, and they allow you to go really fast and agile. So if you're an individual developer or a data scientist, you can quickly get started with AI and machine learning, getting access to the resources, algorithms, and so on. And that can be done based on a number of data sets or data sources. Could be imagery data, as we saw the two examples, but just as well that could be coming out of line of business systems or CRM systems, where you do analysis maybe about sentiment or purchase behavior of your users. And so it's really the core piece of our cloud platform. And of course, that AI platform will be used in a number of either end user or maybe internal applications, or give you some insights in kind of the operations of your application. So that can be applied in a number of scenarios. Now, having said this, when we look at the typical AI development lifecycle, so we go from the left-hand side where we have all of those data sources sitting. Well, we need to find kind of a way of ingesting that data into the cloud platform, bring that data closer to where you have your analytics and your AI happening. So we have a number of ingestion services that will help you to orchestrate and monitor the data coming in. That could be streaming data, but just as well that could be data at rest, which is sitting in existing systems. And then, of course, we need to store that data. It could be, depending on the size and structure of that data, could be data lake or could be other types of storage systems. And then we come to what we call Azure Machine Learning Services. where we are going to do the actual intelligent data science type of activities. So we need to prepare and train our models. It can be done again using a number of services, and maybe you have already some experience with existing services like Hadoop or like Spark. Or maybe you already have some experience using R or Python for actually preparing your work, preparing the data, and training your model on that specific set of data. And then, of course, we need to execute on that model. Once we have defined our machine learning model, we need to apply it to the actual runtime data, the data coming in, flowing in, allowing us to kind of either predict future values, do anomaly detection, those kind of things, which will then ultimately result in either insights or that data, that intelligence being represented in existing applications. So it's kind of the workflow we're going through. Now, if we look at the actual, if we go one level deeper, then what are kind of the technologies that we will be using, or that you have at your disposal in the Azure platform or the Microsoft platform, is all the way at the bottom, you could see that you, of course, need a hyperscale infrastructure because we're dealing with typically we're dealing with massive amounts of data. We're dealing with huge demands on computing resources, and so there's set of hardware available, and depending on your algorithms, depending on the scenario, you may have a need for graphical processing units, so GPUs, or maybe there's FPGA, so programmable hardware, basically, to kind of really have kind of the best performance at the hardware level to run your algorithms. And of course, you have all of the storage management, storage systems. And then on top of that, there's existing software that can be leveraged. And there you could see kind of infrastructure software, such as what the ACS stands for, Azure Container Service. So if you have Docker for running some of your algorithms, maybe we'll have some virtual machines that we need. Maybe you need to run some process in batch. So all of this infrastructure services, we have them, and we have them across the globe. So Azure is a global cloud solution. And then, of course, on top of that, there's what we call it. Well, we call it an open platform for data science, because basically our machine learning and AI platform is very open to existing technologies, because the current situation is that the ML and AI landscape is very heterogeneous. So you have people, as mentioned, that use Python. Other people are using R. Maybe they have been playing with maybe with TensorFlow or some of our technologies such as CNTK. And so there's numerous technologies, and so we're open to run all of these technologies on our platforms. And then ultimately, we have these developer tools and services that you can leverage. So cognitive services, which were already mentioned earlier this week by my colleague, which are these ready-made APIs, either for vision or for image recognition or face detection, or maybe for speech detection, maybe for language understanding, those kind of ready-made services. Or you may have existing AI applications that you already want to use and that you want to continue to use on top of this existing infrastructure. And so this kind of the landscape, or the set of technologies that you can leverage on our platform, and we'll go into more detail in each, in a number of them. And so let's first start with Azure Machine Learning. So when we talk about Azure Machine Learning, there's basically kind of two approaches to Azure Machine Learning. The first kind of easy step into machine learning, because machine learning AI can be very daunting, especially for developers that are new, which are not data scientists, but maybe want to include some AI and want to do some machine learning in their applications. Writing actually code for doing machine learning, writing those algorithms can be quite complex. And so what we have done on the Azure platform is we have created what is called the Azure Machine Learning Studio, which is really a drag and drop environment, a very visual environment for building machine learning models. And it's really a drag and drop environment. So in the browser, you define your machine learning model. And once you have defined your model, you have trained your model, maybe you've done some evaluations comparing different algorithms one against each other to find the best scoring model for your specific set of data. Then you can actually expose that machine learning model, deploy it as a web service. And we'll see in a quick demo how this is done. But it's really an easy step into creating machine learning, which is very accessible. You might say, I have already done some investments. Maybe I've already written some, maybe some R scripts or maybe some Python scripts, for your specific problem, maybe there is already an existing R or Python script available somewhere in the wild. There's numerous scripts and algorithms available. What do I do with this? Have this visual environment? Well, you can actually take and plug those existing R and Python scripts inside of this visual environment as well. And so let's quickly switch now to a demo to see how this works. So for the other people who have joined, if you have any questions, feel free to post them here in the IM window. So I'm going to switch now over to the demo here. So now you should now see the browser window. Okay. So what you should see here in the browser window is the Microsoft Azure Machine Learning Studio kind of landing page. And so the link for that is studio.azureml.net. If you search on the Azure portal, you can get access to the Azure Machine Learning Studio as well. It's one of our services. But it's kind of a direct link into the Machine Learning Studio. So once you land on this, you could sign in if you already have a workspace. And maybe for your information, so Azure Machine Learning comes, it's basically pay as you go, but we also have like a free model where you can just sign up. The only thing you provide is a Microsoft account, so a Hotmail or Outlook.com account, and you can get started. And you have this free shared environment that you can just run your experiments on, just to get to learn the environment that Machine Learning Studio is. And so once you're signed in, you can click here and go to My Experiments. So I've already have a list of experiments here. And I don't want it to now. And what you see here is my list of experiments that I have already created. So you can see a number of them. If you want to create a new experiment, you can just click the New button here, and you'll see that there are a number of samples already available here. So we have what we call a gallery of experiments that you can just take as an example. Maybe you can tweak, maybe there's something that matches your specific requirement. So there's all kinds of algorithms and scenarios. So for example, if you want to do Twitter sentiment analysis or sentiment analysis on existing text messages, basically you can leverage this existing experiment, and you can just open it in Studio and it will just create a new experiment based on that example. And this is what I've done here. So I'm going to switch to another tab window here. And this is basically a fairly simple machine learning model that takes census data, which is basically information about income, about the work situation, background of people, and actually will determine or will try to predict if a given person, given his current social context and education, whether he will make more or less than $50,000 a year. If their salary will be up or higher or lower than $50,000. And so here you can see the main canvas here where you can have all of these activities. And for example, here we have our data that we have that has come in. We can view our data set if we want to. So you have a visualize capability here. So let's look at the data here quickly. And so you can see here there's like 32,000 records in here. And so we have information about age. You can see histogram, working class, education, marital status, and so on and so on. So you can see all kinds of data, and we see so already here the income is lower than or greater than $50,000. So this is a supervised training algorithm. So how does this actually work? So here on the left-hand side, you can basically see all of these activities that we can add to our machine learning model to create it. And so we can do some data preparation as we're doing here. So we're selecting a number of columns from our data set. So we're excluding some columns that we don't need. Maybe we can want to change some metadata. We want to clean if there's some missing data. We can put either mean values, fixed values, and so on, or we can remove rows that have some missing data. And actually the meat of the model, just so to speak, happens here. So what we're going to do is we're going to split our data set because we need to train our model. This is what you see here. We're going to train our model, and in our split data activity, you'll see that we're going to take 90% will be used for training purposes, which means that we'll have 10% actually for validating, then for scoring our model. So we have here 90% of the data split is being fed into a training model activity in which we're going to specify our feature that we want to determine here. We want to calculate the actual income. So this is our main feature for our machine learning model. And then we can apply a specific algorithm. In this specific case, what we want to do is we want to decide, is it higher or lower than $50,000 per year, which is basically a classification problem that we want to solve here. And it's actually more specifically a two-class classification that we want to do. It's higher or lower, so it's binary. And so we're using a boosted decision tree algorithm, which we can parameterize here. So you don't need to know the actual implementation details of the boosted decision tree. You can just get it here, or let's say you want to use another two-class algorithm. Maybe you want to use in this specific case, maybe you want to use the two-class decision forest. So you can just drag and drop it here. And we can just tie it into this specific case here and to disable this one here. And so instead of using the boosted decision tree, we're now using a decision forest. And so this is how you drag and drop activities here on your model. And so we can just wire up the different pieces to have our model trained, and then we can actually score our model, evaluate our model. Yeah. So if you now want to see what the actual results are, you can see something happening here. Letting somebody in the meeting. So once we have defined our model, let me add some more space here, we can actually run this model to see what are kind of the results. And typically what you do as well when you run and train these models, you will be evaluating multiple algorithms next to each other. In this specific case, we're just using the two-class boosted decision tree. You could add multiple ones and then compare them all in one run. So you can do this in Machine Learning Studio. And so once we've run it, we can actually look at the evaluation results. And again, we can visualize here the results to see kind of what is the performance of our model. So we got the ROC curve here. We can look at precisions and recalls. We can see the lift curve, and we can see some numbers about true positives, true negatives, false negatives, and so on and so on. So we can actually get already some measures here about our algorithm, and if you have two of them, you can actually compare them. You can compare the graphs against each other. So this is how you create your model. Now, once we have defined our model, we have trained it, we have chosen the correct algorithm, then we can actually expose and deploy our machine learning model as a web service. And so we can set up here a web service, and I have already created one just for the sake of time. It takes only a minute, but still. And so here I'm updating the model. What you'll see is we'll get a predictive experiment. So basically the version of our machine learning model, which takes a web service input, which will be fed into our scored model, and we'll get the web service output, which will basically get us our final result. Are we making more or less than $50,000? And so once we've done this, we can actually deploy our web service. So we have created our web service. Now we can actually, and I should probably run this one as well. So once we've run our predictive experiment, we will have a web service which is exposed as an endpoint that we can then invoke from an existing application, or which you can invoke from just from a testing interface. And I'll show you how this is done. So what we do as well, so we allow you to kind of use, for example, Excel as a test canvas for testing your machine learning model. Let me quickly show you this. So while this one is running, so the end result of what you'll get here is when you expose your web service and call it from Microsoft Excel, you will get here for the different parameters of our data set. So these are being taken as input parameters for our web service. We will get our scored label and probabilities here. And so here we could say, I want to predict for these sample rows here. And so let's see if we click the predict button, we will see that most of the people that we have defined here are making less than $50,000. Only the last person here will make more than 50,000. And maybe we can change some values here and make this, for example, also a bachelor. Let's see if that will change kind of the score, because here we have a probability of 10%. If we now predict again, we'll see that the probability goes up to 42%. Maybe there's some other criteria that come into play here. And so this is how you can quickly test your machine learning model. So you deploy it and you can test it. And so if you click here to deploy, because this one has run, you will see how we can actually get to the test interface. Yes, I want to override it. And so, as you can see, this is very easy, very accessible for even for developers that have limited experience with machine learning, especially maybe the techniques of writing Python or R, or using these specific machine learning tools that may exist. So it's very accessible. And so here you can see the actual outcome, where you can see these test interfaces, where you can open up your web service to be used from Excel, just for testing purposes. And so you'll have an endpoint for your service, and you, of course, for security reasons, you'll get an API key. So it's just a matter of calling this REST service from your application to get the actual results. So this is Azure Machine Learning. So just quickly showing you another experiment, which is basically here a color quantization experiment where we're going to use k-means clustering. So we're clustering information. Specifically here, we're clustering colors in a given image. And this specific experiment is using existing R scripts. And so here you have the R script activity. And if we go a little bit deeper here, we can actually see that we can use just standard R technologies for code and plug it into our experiment here in Azure Machine Learning Studio. So if you already have existing assets in R or in Python, you can just plug them in. So we have a very extensible model here. Okay. So this is kind of a quick overview of Azure Machine Learning Studio. So your visual drag and drop way of starting with machine learning. Okay, I'm going to switch back to our presentation here. Okay, Machine Learning Studio. So there's a number of benefits. So it's very easy, very quick to get started. You give what we call serverless training and deployment environments. You don't have to deal with infrastructure. It's very convenient, but there are some challenges. Sometimes if you're running, you have very limited control over compute resources. You don't know, maybe for your specific algorithm, you need GPUs. Graphical processing units. Maybe you want to have more control over how you massage the data. Maybe data preparation that needs to happen may be quite complicated. You want to have some options about deploying. Maybe you want to run your machine learning model, deploy it locally. Maybe you have a cluster running locally in your data center. or in your premises, maybe you already have it running at a hoster. Maybe you have a cluster, a Spark cluster. Maybe you have some sets of Docker hosts on which you want to run your machine learning models. So with Azure Machine Learning Studio, you can't do this. Because basically Microsoft, the Azure platform, that decides where we run your specific algorithms. And so there's a number of challenges. Also, yes, you can use R and Python in Azure Machine Learning Studio, but maybe you want to use TensorFlow or some other frameworks. And tools for designing or writing your machine learning models. So all of these things, more flexibility that you might need, which don't come with Azure Machine Learning Studio. It's really a quick and convenient way, but it has its limitations, of course. And so that's why we came up with, we announced it at the Ignite conference like 2 months ago, our Microsoft Machine Learning Services. So here on the left-hand side, you can see the Azure Machine Learning Services, and basically have two cloud components there. So there's first the experimentation service, and then the second one is the model management, and we'll go into more detail what these are, these services. And these are supplemented with basically a tool, what we call the Workbench, the Azure Machine Learning Workbench, which is basically the development tool for the data scientists. So you define, you write your machine learning algorithms and models in this Workbench, which is cross-platform, by the way. And then once you have done all of your development, you want to train your model, of course. So the actual development or writing, the data science part is happening on a workstation, on your developer machine or data science work machine. And then the training and deployment, what can happen either in Azure, could happen on premises, but just as well, if you want to deploy your algorithms, you may want to deploy them maybe to an edge device, an IoT device. Maybe you need to do some AI on a Raspberry Pi device, because that's where maybe a camera feeds are coming in, and you want to do some immediate artificial intelligence processing. So then the actual deployment of the model needs to happen on that IoT device. And so you have flexibility of where you train your models, but also where you want to deploy your models. And so that's kind of all of the challenges that we raised, that were kind of the concerns you had with the Machine Learning Studio, are kind of solved through this Azure Machine Learning Services. So you get flexibility of deployment, of where you train, and also flexibility of how you develop your algorithms. And so how do you get started with these machine learning services? So you actually go to the Azure Management Portal, and there you can go to the AI and Cognitive Services section. And so in there you could select the Machine Learning Experimentation Service. So here you see the kind of the information that you need to provide. So you need to provide an account name, some of course the location. So where is actually the machine learning services? Where is that running? The experimentation service, and then some more technical parts such as a storage account. And so this setup of this service, the experimentation and this model management service, is basically kind of more of an orchestrator, kind of the one organizing the work, and has not necessarily any correlation of where you want to deploy or where you want to train your models. This is just, I need a service that can manage my environment, my project, rather than, and then later on you'll decide where you want to train, where you want to deploy. So it's not because you create the model here, the experimentation service and the model management service in Azure, that everything that goes behind that needs to happen in the cloud. So there you have the flexibility of where you deploy and where you want to train. And so you'll end up with an experimentation service where you see here the details. And I'll come back to that one in the demo. Now, looking at experimentation service, what is kind of the purpose of this experimentation service? So when you write machine learning models, well, you need to iterate and run them and train them very often. And so the Azure Machine Learning experimentation service is kind of the orchestrator of this whole training process. Yeah. So from your command line tools or an existing development environment, maybe that could be Visual Studio Code, but could just as well be another IDE that you want to use. You're going to integrate with the experimentation service, and then you're going to experiment, basically run all different runs using different parameters, different configurations, using different algorithms. All of that is basically your training of your model. You decide where you want to run it, where you want to experiment. Do you want to experiment on your local machine, where you have also your development environment? Maybe it's on a remote server. Maybe it's on a virtual machine running in Azure. Maybe it's on Spark. Maybe it's a Spark server. Maybe it's on a standalone machine learning server or an R server, as the previous name was called. And so flexibility, so experimentation gives you kind of the orchestrator, the organizer of all of your experiments. And kind of the nice thing is it's going to manage the job, so the execution of those experiments. But through source control, it will also allow you to kind of have version control over your different experiments. So as you run your experiments, maybe you do 10 experiments, maybe you do 50, what you want to compare, which one was kind of the best one, and you start comparing the results of these different runs. Now, as you compare them, well, maybe experiment number 17 was the best one, but in the meantime, you've done like 50 and you've changed algorithms, you have changed configuration parameters, you've changed all kinds of stuff. And so the experimentation service is going to basically source control all of your parameters, all of the corresponding data, and the actual code that you submit, all as kind of a logical unit, so that you can easily come back to the state you were in when you ran experiment number 17. So you do a number of experiments, and then when you have decided like this one is the kind of the best one, you can come back and see what was the exact set of data and parameters and program that went with that specific experiment. So you have really historical metadata during your experimentation, which adds a lot of value. So that's kind of the experimentation service. Now the model management service takes basically the next step. Is once you have trained, you have decided upon all of your parameters, you have trained your model, well, then we need to deploy your model. And so model management will allow you to define your target environments. So where do you want to run your production or your test machine learning model? So that could be on just a single node, and that node could be running locally, could be running in the cloud, could be running at a hoster. Maybe you want to run it on what we call the Azure Container Service or a Kubernetes cluster. Because how does model management give you that flexibility to deploy anywhere? It's because it is using Docker. So it's using container technology to kind of package the actual model, all of the third-party dependencies, because I didn't really mention it, but while you do your experiments, you could use any existing frameworks that you know of, that you have been using already. So if you're using TensorFlow, well, you could use TensorFlow for your machine learning algorithm, and we'll wrap it all up in a Docker container, publish that in a registry, your registry of choice, and then we can deploy it to any of these target environments. So locally, in the cloud, on a Kubernetes cluster, on a physical box, but just as well on a Spark cluster or on an IoT device. So if you want to have the AI machine learning happen close to what we call the edge, so close to where the action is happening in case of Internet of Things. So where you have maybe the sensor data coming in, or maybe where the camera feeds are coming in, and those kind of things. And so this is kind of the basis, and model management will kind of manage the deployment of your models, your trained models, and in the different environments that you have chosen, that you have configured. And so that's kind of the purpose of Azure Machine Learning model management. And so we have support for, again, as I said, different technologies, and we'll do monitoring of how the deployment is going. And so it's based on kind of a standard container technologies. So now comes, so we looked at the experimentation part, we looked at the actual model management part, so the deployment of the model. So how is all of this being done? The development. So, and for this part, it's kind of the data scientist's work machine. So for that, we have what we call the workbench. What is the workbench? You could see it as a code editor, but it's really an advanced one. So workbench does allow you to kind of write your machine learning models. You can write your Python, use your Jupyter notebooks. We have the notebooks embedded within the workbench. It of course integrates with the experimentation and model management services, so that you can easily run your experiments from within the workbench, see your run history, compare different runs, but also, it's kind of the last point here is it has a set of what we call data wrangling tools. So you can massage your data in a very easy, very intelligent manner. And it's really the part where you need to prepare your data, which is very often when we run projects, we notice that the actual data preparation phase of a machine learning or an AI project takes between 70 and 80% of the time. So the actual intelligence part is only like 20 to 30% of the time you spend on the actual machine learning algorithms and AI part of the project. So it's kind of, and so what we wanted to do is kind of cut down on the whole preparation of the data part. So how can we easily create an environment for a data scientist where he can actually massage the data and prepare the data for the algorithms in a way faster manner, so that you can actually focus on the algorithm side of things. And so how we do this is using a technique called PROSE, and the link is in the slides, and we'll be sharing the slides here. Is actually, and we'll see it in the demo, is you can actually prepare the data by using examples. So you have a number of columns of data. You know what the target data should look like. Well, you can actually provide an example, and through intelligence, so the tool itself uses some form of AI to actually create the script, the corresponding script to transform the data in your target format. And we'll see it. You'll see it working. You need to see it to actually believe it. And so one part I wanted to mention here as well on the actual development side, so you can actually integrate the different services within Azure Machine Learning in your existing IDEs or machine or command line tools. So it's very accessible. So you can use whatever you have been using before. So let me switch now again to a demo. So coming back to the monitor here. There we go. So this was the Machine Learning Studio. So if we go to Azure here, quickly show you here how do you go and start with Azure Machine Learning. So we're going to click on the Create Resource. If it is working. Seems to be. There we go. So you can go to AI and Cognitive Services. Quick question, can you still see the screen? Okay, there was an issue presenting the screen. Okay, you should now see the screen again. Can you see the screen now? So can you see the browser window right now? Just checking up on you. Okay, good. Let's switch back here now. So when you choose AI and cognitive services, here you could see the machine learning experimentation. So I've already created one, so it takes like 1 or 2 minutes for it to create an experiment or an experimentation service, sorry. And so in here on this landing page, once your experiment has been created, you will find also the download links for the machine learning workbench tool. And so for Windows, but also for Mac, you can get it here. And here you'll find more links to how you start to configure to create your environments, your target environment. So you have some quick links to get started. So once you have your experiment created, you will be using the workbench. Let me now switch to the workbench here, which is this environment here. And let me now show you here, when we create a new project, just click here, new project. Again, we'll have, you can give your project a name. So for example, my iris project, because what we're going to do is the classifying of iris, the flowers. So here you can specify some description. You can provide here a Git repository. So that's kind of for the version control part. You can create multiple workspaces, which kind of groupings of projects. And so there's a number of sample templates here. You can look at using TensorFlow, using CNTK. Using Spark and so on and so on. So there's a whole number of samples here. So for the sake of this demo, we're going to use the iris classification. So let's create this one. So this takes just a few seconds. And so what you see here is some introductory page, quick start information. You see some references if you want to go and work with the command line interface, because whatever we do here in the workbench, you could do as well using the command line. Yeah. And so here you see a number of tabs. So we have our home, our dashboard. Then we can have a view on our data. So the data wrangling part will be happening here. So we have a data source, we have the data preparation phase. We have notebooks. So these are the notebooks that you can then run to go step by step through the actual code. We'll have a view on our run history. We don't have any runs so far. And then we can go at the actual files. So let's look here, our iris file, and basically here you can see the actual algorithm written in Python of the specific classification of iris flowers. Yeah. And this is actually done. Let me quickly show you kind of the data on this data set. Gives you a number of columns. I'll show you kind of the final version when we have the actual value or the names of the different columns. And so we have a full data set here with data. Now, what can we do? What if we want to run the specific case? So we have our algorithm here, our machine learning model for the classification. Well, we actually can run it here, straight from here, and we can decide which environment we want to run it on. Just natively on my machine. Do you want to run it on a Docker container? You're using Spark or Python, so PySpark. We can provide some arguments, and as we create more environments, these environments could be remote, could be at a hoster, whatever you decide. This will just integrate in our workbench, and so we can provide an argument here and just run it. And so you will see our job being submitted, and typically the first run takes about like 20 seconds for it to finish. And so we can look at our run history. And we can see all of our runs, and then we can see that already one has completed. You can see the duration, the accuracy, the actual value here of our run. And so you can see here, once it's completed, we can go click on this one, see the outputs. So we can see the recall, precision, some thresholds here. We actually have the pickle file, so the actual model, the trained model is sitting here. So all of the output of our run, and as well as the actual log files. And you should see actually the graphs as well. So the ROC curve, which doesn't seem to be running now. And so using this, you can get full details. So here we see our ROC curve for our specific, well, maybe there's a connection problem here. And so with this, we can actually run. And now let me show you how this works if we have multiple runs, so that we can compare stuff. So in this run.py, we have a script which will, a Python script, which will just iterate over specific values of input parameters. And so let's quickly run this. Just for the sake of time, let's open the command prompt. And we'll run Python of run.py. So this will just execute this Python script, and it will go and iterate and launch our machine learning experiment. So using AZ, which is the Azure command line interface, machine learning experiment submit. And you can see that already we have one that's running here. And so if we go to our run history and see all of our runs, we'll see that we have 2 completed now. And there should be another one kicking off. So we have a 3rd one, and it will go and add, and it refreshes here. So the 3rd one is running, and it goes on and goes through all of the iterations of our runs. And so when we have, let's say we want to look at this 2nd one, what you'll see here is we can actually compare specific runs. So we can add a run. I want to run number 2, and I want to compare it, for example, with run number 5. So there you'll see side by side. You will, as it finishes, I think I've chosen one that's still running. Apologies for that. But you can then side by side compare different runs of your algorithm. So this is kind of the workbench, the run history that you see here. Now, for the data wrangling part, while this one is running here, I'm just going to close this project and open up my data prep project here, where I have a more complex data set. And so here, for example, we have information about weather in Boston. So we have some date information, weather type, some hourly temperatures, humidity, and wind speed. So those kind of values are here. And so what we're going to do is we want to prepare our data. And so we can see first some metrics about the data. So we can see that the date column, some histograms here. When we do prepare of our data, I have already done one here. And this is the weather data, apologies. We can start massaging our data. And how does this work? So one of the things we could do, let's say we will have this date and time information. We want to split this. So we can say, we can right click on this column and say, well, split this column by example. Already, because the date and time information, the tool itself will recognize these kind of fields. So it automatically splits kind of the date and the date part and the time part. But let's say we want to do something more intelligent. We want to group in blocks of like 2 hours. What we can say is we have this column here, and say, okay, I'm okay with these 2 columns. I can say I want to derive a column by example. And so let's say we have here our date. Let's say we want to specify which hour block is this in. Now we could say this is between, taking this example here, this is between 6 a.m. and 8 a.m. because it's at 6:54, like this. Now what will happen is the tool will detect, based on this example, it will derive the different other dates and do the same thing, the similar thing. It has the intelligence to do so. And so it's analyzing the data. We could say we're happy with this. And that's kind of some of the things we could do already. And that's how we can prepare the data. Maybe you want to filter the data just on a given type. So we want to filter our column here, and it should only be just take the data which comes from weather stations of type FM15. Again, we can see that we have our data has now been reduced. So we had 30,000 records. We now have 18,000, and so on and so on. We can filter data. We can start grouping. We want maybe you want to see value counts here, where you want to see how many of each of the dates do we have. Those kind of things. I have another data set here, which is bike data. And let me take the preparation of the bike data. The nice thing here is it's for bike rental, a bike rental service. And there's like two columns in here, which are, as you can see it here, the latitude and the longitude. So let's select these two columns here. What we can do is we have inspectors which allow us to map this information. So let's increase our window size here. And so now we can see on a map, this latitude longitude has been plotted here on a map. So we get nice insights in here. And again, we can do some grouping. We can do transformations. So we can add scripts as well. To find outliers, those kind of things. So there's a whole visual way of and very easy way to do your data preparation phase of your project. And so once we have trained our model, we have prepared our data, we can actually execute this. And the nice thing is we can generate the data access code for this specific data preparation. So whatever we've done in a visual manner, we can now generate a Python file for this. And this will be then taken into account when we actually run and deploy our model. It will do everything it's needed to do so. And so one of the things we can do as well is then publish using model management. And I'm going to switch here to a command line prompt here. We can use model management to define our environment list. So what I've done is I've created a local environment running on my machine on a Docker host. So I have a local environment. I can look at what services are running here. I'm going to like this real-time service up and running for the Iris app. And we can actually execute this when model management kicks in. We can actually deploy our trained model as a web service, similar to what we've done with Azure Machine Learning Studio. But here, what happens is you can actually have choice and flexibility of where we deploy. And so we can actually run our service and give it some input data and see, given this set of input parameters, we'll get the Setosa type of iris flower. So we have deployed it locally. We've trained our model, done the data preparation, we deployed it locally, and now we execute it locally as well. So we can do everything on our machine. We have flexibility and choice of where you deploy. Now, switching back to our slides. Let's quickly take this one here. Okay, so we've seen the two Visual Machine Learning Studio versus the Workbench and the Azure Machine Learning Services. What can we do with Microsoft R? So that's kind of the machine learning using Python. And maybe you have been using R for doing your machine learning. So again, there you have multiple choices for deploying your R type of workloads. And so you have the R client, which is free. And then you have again the choice of, do you want to execute, train, deploy your R models either in the cloud or on premises? So and again there, you can run it on virtual machines or run it on SQL Server, because R is now part of SQL Server. SQL Server 2017 has integrated R and Python support. in it. So if you want to run your R script on data that is sitting in your SQL Server database, you can now bring your R onto the database, close to where the data is sitting. So you no longer have to run something alongside, transport the data out of your database in some other format to be able to do your R. You can actually do it integrated within your database if you would want to. And again, there's ways to deploy your R on the database on a standalone virtual machine, but just as well, you can also run it on Hadoop. So we have our server for Hadoop and Spark as well. So again, flexibility of where you want to run. And so regardless of whether you're using Python or R, again, you have flexibility of deployment of running. And again, you can deploy your R algorithms and models as a web service. So very, again, I think the message comes back again. You have flexibility of deployment and just publish it as a web service, and it's up there to be integrated in existing applications and environments. So just a matter of doing a REST call to get to your training and your maybe prediction models. Okay. Now one additional thing that I wanted to mention. So far we've been looking at machine learning. You may have experience with, or you may be interested in what is called deep learning. So deep learning is kind of a variation of machine learning. And so one example of deep learning technology is TensorFlow. But we have been working for like 5-6 years already within Microsoft Research on what is called the Microsoft Cognitive Toolkit, and is being used in many of our AI services in the background. Is the Microsoft Cognitive Toolkit, or as it used to be called, CNTK, which is a deep learning library. And so it allows you to easily create deep learning algorithms. And so it will allow you to create these neural networks, deep learning neural networks, and again, a fairly easy manner. Why do I say fairly easy? Because the concept of course, of deep learning is not that trivial. Of course, there is quite some data science behind the scenes happening, choosing the right algorithms and learning models and algorithms is not a trivial thing. But the technology takes away a lot of the burden to actually run these deep learning models for you. And so again, you can use Python. So here you just see an example, but you have a number of examples published, end-to-end examples with the accompanying data sets. So yeah, you can actually go run through the CNTK to do your deep learning. So you can use Python, you can use C#, or you can use C++ as well. So there's again multiple technologies available, and you can run them on Windows, on Linux. So it's cross-platform again as a technology. So we don't enforce you to use either one or the other platform. It's up to you to choose where you want to run these. And so yeah, this is just to kind of demonstrate kind of the deep learning for specific problems. They can give you a lot higher accuracy in getting to the results. But know that CNTK is there available to you. You can go to cntk.ai, with the links are shown at the end of the presentation here. If you want to do deep learning as part of this InQbet exercises or challenges. So it does exist. Now, one thing I wanted to mention here to give you kind of a quick start, I already mentioned in the beginning, there's a whole range of technologies already existing when it comes to machine learning and AI. And so you have CNTK, you have TensorFlow, there's R, there's Spark, and all of these things, all of these technologies exist, and they continue to evolve. If you want to play with these, it takes a lot of time and effort and configuration to set this up in your development environment or even a runtime environment. It takes a lot of time to get set up. And so what we've done is we have created a number of what we call data science virtual machines. And so these are ready-made virtual machines. So we have them both in Windows and Linux. They're hosted in Azure. And they basically contain, and here you just see kind of a sample of the different technologies that are installed already, ready for you on these virtual machines. So what you do is you spin up such a virtual machine. Once you spin it up, it takes like 5-6 minutes. You are ready to go with each and every one of those technologies. So you want to do CNTK, you want to do TensorFlow, you want to play with it, do some trials. Well, you can quickly start up such a virtual machine and get going in a matter of minutes. And if you don't like it, just try something else. And if you're finished, you can just throw away the virtual machine and get started anew the day after. So this are very easy, and just in Microsoft in the Azure portal, you can just search for data science virtual machine, and you'll find the different versions of those virtual machines. So just a matter of minutes. Now, concluding, we've reached kind of the end of the session. Coming back to our machine learning and AI platform. So we're building on this hyperscale infrastructure, which is Azure, and a number of technologies that we provide to you, as well as hardware capabilities, so CPU, GPU, and in the near future also FPGAs. On top of which you can run an open platform for data science, whether it's Azure Machine Learning Services, the Machine Learning Studio, maybe you want to do R, maybe you want to do other open technologies, you can do so and integrate them inside of your AI applications. So for your information, here kind of a flow chart of what technology might be most appropriate, kind of decision tree to choose kind of the proper model for your machine learning and AI solution. So you'll get the presentation with the slides, so you can look at this in more detail. Finally, I want to give you a set of links. And kind of the last one is important. I'm just going to switch to this slide here. If you want to get started with Azure for free, so here on the bottom right-hand side, you can find a quick link to get access and to get started with Azure for free. Try out all of the services. Hopefully, you'll be using some of the services that I've referred to in this session. But yeah, just try it out, play with it, and just let us know what you think of it. With that, I want to thank you for joining this call, and yeah, feel free to get in touch with us if you have any further questions. Thank you for joining, Daniel, and a nice weekend to you too.